So, a very good afternoon to you, one and all participants. Welcome you to the final day of this online faculty development program organized by our PG and Research Department of Mathematics. So, it's a pleasant day. In this pleasant day, I invite our assistant professor, Dr. Safina Devi, to welcome the gathering. Ma'am, please.
Yes, warm good afternoon to one and all. I am overwhelmed to get this opportunity to welcome everyone for today's program. On behalf of V.O.Chidambaram College, I welcome our chief guest, Mr. K. Victor Rajan, Chief Manager IT of VOC Portress Thoothukudi. Welcome, sir.
Thank you.
I extend a warm welcome to all the participants, all my colleagues, and everyone else responsible for today's program. Welcome to you, one and all.
So now I request our head and the coordinator of this faculty development program, Dr. A. Nagarajan, to introduce today's resource person. Please, sir.
Yes. I am very proud to say that Victor Rajan is our old student. In 1990, he has completed a BSc in our college, and he's a very good student. And not only in character as well as his studies, and his fellow mates also very nice. During those days, they are very well concentration on their studies and a very good team they are having. And still now they are in VOCC alumni also we are meeting, and we are very proud and we are very happy that all those our students are well settled. So as a teacher, we are very proud, and also now I am very proud to introduce Victor as our old student. As well as I want to say a brief introduction about him. He is a well experienced software engineer with more than 25 years of industry experience. He has completed ME in Computer Science and Engineering from College of Engineering Guindy, Anna University, and completed his PhD degree in Computer Science from Computer Engineering from Atlantic International University, USA. He started his career in 1994 as software developer, and he has worked in reputed organizations like HCL Technologies, Oracle Corporation, eBay, Infosys Limited, etc. He was a key player in the development and release of Oracle database for Solaris 64-bit operating system in the year 2000. His recent research area is artificial intelligence and machine learning, and he has published many articles in predictive analytics using machine learning. Currently, he is chief manager IT at VOC Portress. In this role, he oversees the IT operations of VOC Portress with a major focus on cost optimization, performance, and reliability. With this introduction, I hand over this session to Dr. Jackson.
Thank you very much, sir. So, first of all, on behalf of our PG and Research Department of Mathematics, I would like to place our sincere thanks to our proudest alumni, Dr. K. Victor Rajan, for accepting our invitation to deliver a lecture in this 1 week online faculty development program. And thank you, sir. Thanks for accepting our invitation
Thank
to
you,
render
sir.
your hands to our department once again. So now the time is yours, sir. So I hand over the session to you. We are awaiting for your lecture on data science. Please, sir.
Thank you, sir. Good afternoon, everyone. I'm really excited and I'm thankful to our HOD, sir, Dr. Nagarajan, sir, and our organizer, Professor Jackson, sir, everyone, for giving me this opportunity. And they have arranged a session on data science, which is really an emerging topic in the industry as well as the research area. Uh, since this is a really a new field, many people might be thinking, what data science has to do with the mathematics? Why we are discussing data science topic in a mathematics session. We will cover the relationship between mathematics and data science, what really mathematics is doing in data science, and also see some of the applications of data science. We may not have time to go in depth to discuss some research, algorithms, etc. But I hope it will help us to get a complete picture of the relationship between data science and machine learning and mathematics, how mathematicians can play an important role in the research and industry related applications of data science area. Okay. I again thank our sir and all the participants for joining this session. I will now start sharing my screen, and we will go to the technical session. Okay. Sir, is everyone able to see my screen?
Yes, visible.
Okay. Good afternoon again, everyone. The topic for today's discussion is essential data science topics to real world applications. This data science has become a really hot topic of discussion in the academics and research community as well as in the industry. We will see why it is picking up that much momentum and what significance it has to do with research as well as the business community. This data science is not a, new branch of study or a branch of science. This has been there for a long time in the form of statistics, data analysis, and also computer science. With the availability of high performance computers and a large amount of data to process the data, this data science has become a separate field of study, and many institutes are offering MSc data science courses, ME data science courses, MBA data science courses. But it is not a new branch of study. It is a combination of mathematics and computer science. So in this session, we will see the mathematics concepts which are used by the data science experts. If we want to give a clear definition or a brief definition of data science, data science is nothing but a branch of study which uses computer science, statistics, and some machine learning algorithms, visualization techniques, and human computer interactions to collect the data, clean the data, integrate the data, and then finally present it for analysis and visualization to make useful decisions by decisions makers like government organizations, business organizations, academicians, etc. Okay. This is a combination of three major science subjects: mathematics, statistics, and computer science. We will look at the topics of mathematics which are playing key role in this data science field. The goal of data science as of today is the industry is trying to come up with the data products using the existing data. We try to analyze the data. We try to present it in a very good form so that decision makers can easily uh, find out the results and make quick decisions, and also the predictive analysis using machine learning. So the data products are available in the form of software products and our computer algorithms, etc. If you want to visualize this data science, this diagram shows the components or the science fields which are part of this data science. Maths and statistics, if we see in the uh, top right circle, mathematics and statistics play an important role in this data science. Uh, then comes the machine learning and the traditional research. So when we come to traditional research, we will definitely know that the research is based on the existing data. We collect the data, then analyze it, and come up with really good results which will be useful for decision makers. So this data science is nothing but our research approach combined with mathematics and statistical techniques, and also the machine algorithms in the computer science. Everything put together, this is coming up as a new data science field, which is contributing to the industrial growth as well as financial sector like banks for analysis on prediction of all our financial growth, banking products expansion, etc. On the other hand, people are also using this for military and hacking, etc., which we see that hackers also use and military purpose, and other people also misuse this machine learning algorithm and artificial intelligence. But we will not touch upon that. We will concentrate on maths and statistics techniques, where which we can focus for research and also taking up industrial projects. Why this much excitement all of a sudden? Why universities are starting up MSc, MTech, MBA courses in data science? Why there is a huge demand for data scientists in the industry like banking sector? RBI has started its own data science lab. Why all this excitement? Over the year of 50 or 60 years, all the organizations have collected lots of data. Everything in the is in the form of printed sheets or Excel. People will have to manually analyze and come up with some ideas and predictions, etc. And now, with the amount of computing power available, this data science field uses the existing data and also the mathematical formulas and computer science algorithms. We develop products which can help to make decision without human intervention. If we provide a set of data and also a computer algorithm, the algorithm will tell you what is going to happen over the period of next 1 month or 3 months in the retail industry, in the financial sector, etc. So it helps us, the decision makers, to make very fast decision without human intervention. And also it is helping people to understand the current situation, what is going on currently, is there any risk involved, is there any opportunity which the business organizations have not explored. The analysis will highlight all those factors, the variables which are present in the existing data set. Predictive analysis. The predictive analysis is nothing but using the historical data, we come up with the forecast for the future. We forecast sales numbers or population growth or what is going to happen in the future. So this is the field where most people concentrate on by coming up with the new algorithms, developing new software projects, etc. So this predictive analytics is nothing but data science and machine learning. We would be hearing lots of job opportunities. We need data science and machine learning experts. And we would be hearing lots of conferences going on where people present lots of research papers, algorithms, data science and machine learning. So what it is actually doing, it is coming up with an algorithm or an approach to use the existing data and forecast the future values. So that is where we will spend more time today and see how many mathematical formulas and statistical techniques are used. uh, the three topics which are really important and for any data scientist to understand before starting a research or before starting a business project are mainly data visualization, data analysis, and data analytics. What is data visualization? This is nothing but pictorial representation of the data. Normally, people who conduct surveys like traditional polling, by filling up questionnaires, by making phone calls, the statistical experts will collect samples and gather a huge amount of population, or some we pick up some random samples, which will be in the form of table, two-dimensional table with rows and columns. Decision makers like a finance minister or a RBI chairman will not be able to understand anything if we give this Excel data to him. So what they need is a pictorial representation of what is going on in Indian economy, what is going on in the banking sector, how many money laundering cases are coming up every year, how many defaulters are there across India, state-wise, etc. So the data visualization is a mathematical technique which converts this two-dimensional data to pictorial representation and presents it to the decision makers so that they can easily find out whether there is a linear trend, whether there is a cluster, whether there is a classification among the data, or whether the data is completely useless. It has lots of noise and null values. The survey is lacking of representation of the complete population. We might have to go back and do the survey and collect data again. So this is the data visualization that will help the decision makers to take a quick decision. The second one is data analysis. Sometimes we also call it as exploratory analysis. This is nothing but understanding what is there in the current system. By applying our statistical methods, we derive some results in the term of probability for the futures or the values of the current system in terms of percentage of sales going up, percentage of sales going down. Is there a relationship between the season and the discount and the impact of sales, etc. All these things we do using the statistical method. As mathematicians, we all know the time series, correlation, Anova. We will see some examples. This is purely data analysis. So the data analysis job is nothing but to pick up a correct mathematical or statistical formula, apply it on the existing data, and give the current results to the decision makers. Data analytics. Data analytics, for example, we might be hearing about the weather forecast in TV and radio since our childhood, but it is no longer a weather forecast people are interested in. Everywhere we go, they want to know the prediction. For example, we go to the train ticket counter and then book a ticket. The ticket clerk says uh, you will get an RAC 24. Then the passenger will want to know whether it will get confirmed or not. So the IRCTC system has come up with a prediction system. Your RAC is 24, but you have 90% probability for confirmation. Similarly, a student wants to get a medical college seat. He says, my NEET score is 508. Will I get a medical college seat in Tamil Nadu? So how these predictions can be made unless we have the past historical data and also an efficient formula or an algorithm, this prediction cannot be done. So that is why people are investing lots of money to train data scientists, conduct lots of conferences to come up with algorithms so that the prediction will be of very high accuracy. So this mainly machine learning algorithms, this is where we employ lots of statistical formulas and mathematical techniques. This will concentrate in this session. Data visualization, unless we first visualize the data, we cannot move on. Analysis and prediction will not be just possible. Because when we look at the two-dimensional data, no one will have time to go through 10,000 records and find out the relationship. So the data importance of data visualization is mainly to use our mathematical charts, graphs, maps, whatever we have in our mathematics, identify the right diagram. You can take the input data, give it to this mathematical tool, represent it in the form of visualization, charts, graphs, maps, etc., so that the decision makers can quickly identify whether there is similarity among the data, whether there is huge amount of error, whether there is a trend in that data, any outlier deviations. So all these things can be quickly understood by the data visualization. So the first job of data scientist is to choose a right tool to present the data to the decision makers. If we present a table, for example, there is an institution which has lots of students. their mark and then gender, male or female. The principal or head of the department will not be able to tell whether the boys are outperforming girls or girls are outperforming boys, or what is the average performance of the class, what is the average score. He may not have time to go through 40 entries and then do the mathematics. So that is where our data visualization helps. We as mathematicians choose the right diagram, which diagram to use to present these marks of the students to the HOD or a principal. So the top authorities will just take a look at and then simply say, hey, our boys are not performing up to the mark. We need to come up with some strategy to improve their performance. Or no, our average is far below the competitor, that college average. We need to do something to improve our exam performance across the university. So such things can be taken quickly by the decision makers. So that is why the data visualization plays an important role in the data science field. How a data scientist can do it. We mathematicians know that there are lots of charts. The first thing, whenever we say graph, we will draw a x-axis, y-axis, and then put the dots there and then draw a line chart. So this is the basic chart. Anyone we used to draw from our 10th standard, 12th standard, etc. But there are lots of other charts which are available in the data, which are useful for decision makers. So as a data scientist, one should have a clear idea of what are the tools available in the data visualization field and which diagram will be suitable to present the current data, the existing data to decision makers. Lots of data like line chart, pie chart, bar chart, scatter chart, we mathematicians know. So we need to find out which tool will correctly represent the data to the decision makers. So this is the first field where a data scientist should concentrate on. So what is the real benefit? What if we skip this data visualization and go to data analysis? Sometimes we may not be even having useful or correct data in the collected sample. Everything will be some null values, boundary values, etc. If we start analysis, finally we will not be able to find out any useful results. So unless if we visualize, we will be able to find out what it actually contains, whether it contains interpretable results, whether we can present it to the top management, or should we discard it and then go for another survey. So that is why we do the data visualization first, and it helps us to identify all the incorrect and boundary values, null values, everything, and pick up the correct value for further analysis. And another thing is storytelling and decision making. If we present it to the top management, there is no need for a data scientist to talk anything during the board meeting of an organization. Decision makers will automatically arrive at conclusions just by looking at the chart we provide. So that is the first thing every data scientist will do before starting the next phase, which is called data analysis. Data visualization tools are available ready-made. Almost all people have Microsoft tools in their computer installed. So MS Excel can draw the primitive diagrams like line chart, pie chart, bar chart, etc. Commercial organizations use a license tool called Tableau, which has lots of other things like heat maps, pairwise charts, etc., which are used in the industry. And people who are in the academics and research field, they use packages like MATLAB, Python, or for us, Plotly is one of a powerful tool which can be used to draw all the charts and graphs during our research time. Next, how to do a very good a graph or a dashboard and present it to the users. This is nothing but there is no hard and fast rule. People will gain through their experience, but there are some tips provided by experts. You choose the right choice of visualization. People who have in-depth knowledge in mathematics and statistics can easily tell which will be the right diagram to show the marks of a class in a college, which will be the right diagram to represent the number of deaths due to pandemic across the country. That state-wise statistics will be available. So a pie chart or bar chart, histogram. So the mathematicians will be able to tell which chart will really help people to understand it quickly. The second one is consistency. If we are doing a research project or industrial project, we should maintain a consistency, use the same diagram and same effect before analysis, during analysis, after analysis, and while showing the prediction at the end. Similarly, personalization. Some people, some organizations, colleges will have their own color schemes, fonts, etc. All those things which are really useful for a data scientist to first understand and then present it to the decision makers so that people will be pleased with the work of the data scientist. Next is data analysis. As I said, if we look at the visualization, we will come to know what happened. There is no need to explain what is going on. People will understand whether there is a linear growth in the sales of a product, whether there is a linear growth in the population, whether there is a linear growth in the performance of students in a college from the first semester to sixth semester, or whether the performance is declining. All those things will be easily understood if we represent it in a line diagram or a bar chart, etc. So the exploratory analysis is nothing but conducting further analysis based on that visualization, applying the formula and telling them, hey, what is the percentage of growth we achieved in this year. By looking at the diagram, we can say, okay, there is a growth. But what is the percentage? What is the relationship between the dependent variable and the independent variable? This is the work we do in the data analysis, which we call it as exploratory analysis. And this is nothing but statistical methods. For example, COVID is spreading very fast. Every year, people say second wave will come, third wave will come. So, for a decision maker like an organization or a government to find out whether we need enough beds in the hospital, how many beds are needed in April, how many beds are needed in May, what was the situation from the history. So if you tell them that 50 beds were needed in May, 60 in April, March, etc., no one will understand. If we represent it and say, okay, this follows a time series with the peak happening once in 3 months. It goes up and then it comes down. It goes up and then it comes down. Then the problem is solved. People will not ask you how many beds I need in next month, the second, third quarter, third quarter, etc. It says it goes up everything 3 months and then comes down. So what the data scientist did, he did a time series analysis and then represented it in the chart, and also probably we can say the percentage of growth every quarter, etc. So the time series is the basic analysis every statistician will do when we get a data which is nothing but a univariate analysis. We have a single variable which is dependent on a independent variable. As we move on, we might get complicated data, which is nothing but a bivariate distribution or a multivariate distribution. For example, is there a relationship in between person's income and age over the period of time? So such things, analysis we may not be able to do during visualization. We might see an upward trend or downward trend, but we need to give a clear number: 30% growth, 40% growth. Salary goes up by 10% every year as a person gains experience. So such things are possible using our statistical methods. Normally, we know that the first thing we do is correlation coefficient. If there are two variables, we calculate the correlation coefficient, which is a positive relationship, negative relationship, or no relationship. We can give it in terms of numerical numbers. So, as a data scientist, people will use our statistical formula to arrive at conclusions. The third one is multivariate analysis. The three or more variables and even more than three. We will not see, we will just go through it because we don't have time to make deep dive. We will have to jump to predictive analysis. So analysis of variance, Anova, we all know that it is very rich role in the research field of computational biology, computational chemistry, etc. People will have lots of data which will have multiple dependent variables: age, gender, income, the growth of a plant, uh, similarly growth of animals, their food habits, etc. So analysis of variance is used to find out the relationship between the variables in a multivariable variate distribution. Examples are our computational biology, medicine field, where we analyze the relationship between food habit, the age, and diabetics, cancer, etc. We do all analysis by taking the historical data of people's food habit, their age, their physical exercise, and then see whether this person will have diabetes or not. Similarly, cancer. The people who live in a particular city where there is lots of pollution and their food habits is like this, no exercise, they will have very high chance of getting cancer. So all these analysis variants tools are used by many of the scientists, which are provided by our data scientists, mainly statistical formula. The factor analysis, which we may not have used in our colleges, but this is picking up really importance due to the deep learning in machine learning. There is a principal component analysis. When the data set goes very large, millions of records with the 5 attributes or 6 attributes, how to feed this into a computer which can process probably millions of data in few minutes. If we feed billions of data, it may take one day. By the time we do the training, people would have already found out alternate solution through their manual reasoning. So this principal component analysis helps to identify the various factors and reduce the dimension. Probably if we get time, we will spend more time on this factor deep learning algorithms in future. Currently, we will quickly go through our statistical methods which are used in our data analytics. So the data analysis, this is something whether you are a researcher or a job seeker, when you go and present your result to someone else, the first question they will ask you is, how did you choose this algorithm? Why not the other one algorithm? On what basis you chose this predictive algorithm, linear trend or a probability model? Why didn't you choose regression? Why did you choose Bayes formula? They will first thing they will ask is, on what basis you came up with this predictive algorithm. So unless we do data analysis, we will not be able to find out which algorithm is suitable for prediction. The prediction, there are more than 12 mathematical formulas used for predictive analytics. Unless we do analysis, we will not be able to find out the right algorithm for future forecast. Uh, yeah, even after doing data analysis, we might have to do trial and error, try multiple algorithms and find out a suitable one. But the data analysis really helps a researcher or an industrial data scientist to pick up the right tool for predictive analytics. So it's very important. After getting the data, we put it in the form of table, we visualize it, and then do the analysis. So the analysis is nothing but identify the relationship between the variables, whether it's a bivariate distribution, multivariate distribution, whether there is a correlation, direct correlation between the variables, or whether it's a probability distribution, which we cannot use in our one of our linear trend analysis. We will have to use some other method. All those ideas we will get only after doing the data analysis. So that is the fourth point, is this data analysis helps us to choose the right machine learning algorithm for predictive analytics. So the data scientist first, he visualizes the data, then does a preliminary data analysis. Industries are looking for data scientists with machine learning knowledge. This exploratory analysis may not be of huge demand in the industry in future, because everybody wants to know the future result, predicts. I will give you data, you give the prediction in 3 hours, 4 hours, or I will give you millions of records today evening. Tomorrow morning you come and tell me what percentage of growth we can achieve if you continue this trend, if you follow the same sales strategy, if you follow the same advertising strategy, how much percentage we can increase. So that is the number normally decision makers will expect from data scientists. So data scientists should be able to pick up a correct algorithm. uh, for this, he has to do a data analysis. So the analysis of the statistical formulas we can use. Already tools have been widely used by people in the academic field as well as the industry. Academicians and researchers are using uh, open source tools like R programming, MATLAB, etc. SPSS is a statistical package. Similarly, industry experts are using Tableau, SAS, Python programming, etc. A data scientist should pick up a tool, and he should familiarize himself with the programming tool or a package like Tableau or SPSS, so that he can quickly give the input and get the output, and predict the results, present the result to the decision makers. So, yeah, complete understanding of the mathematical formula and a right tool for analysis, a software-based tool, are really needed for a data scientist to do his job efficiently. After we do analysis, the data analytics is the challenging part. Now, every advertisement we see that we are starting our MSc data science with machine learning, or MBA data science with machine learning. The industry will need 40,000 data scientists in the next 2 years. So the industry needs not data analysts, they need data analytics, data scientists with machine learning experience. So for every mathematician and a statistician, it has become a compelling need to understand a little bit of predictive algorithms to continue our research either in the industry or institute. Okay. If you want to take up an industry career, you should have a good understanding of machine learning algorithms and programming language. Similarly, if you want to do your research in data science and continue to be a researcher or academician, it is really important to be familiar with the statistical package and also understand some of the machine learning algorithms. So the data analytics is a field which is picking up very fast, where people use the existing data and apply a mathematical or a statistical based machine learning algorithm to predict the results. So what is actually a machine learning? Why it is picking up recently? Machine learning is a subfield of artificial intelligence. This artificial intelligence is in the under research, and it keeps evolving for the 40 or 50 years. Uh, this covers the wide variety of fields like expert system, robots, machine learnings, and now self-driving cars, etc. But this machine learning did not get importance like robots or expert systems 30 years back, because all our computers were personal computers, and we would need a huge amount of money to buy memory and processors, feed the data, wait for hours to see the output, etc. After 2000, with the computing power, the blade servers and the high performance servers, and the easily configurable cloud-based servers, we can add memory and processor dynamically. If you find that our data is making the server very slow, you can dynamically go and add it in and start your project again within few minutes. So the computational power and the increased capacity of the servers has enabled the researchers to concentrate on machine learning algorithms, which is a subset of artificial intelligence. Though robots, expert systems are also uh, having their own market as well as research importance, this machine learning has picked up in the past 10 years due to the available of large amount of data and high computing power. And this has enabled our mathematicians and statisticians to use our knowledge and our theoretical knowledge to apply and come up with the new algorithms as well as turn the existing data into data products. The larger set is artificial intelligence, which is purely computer science and robots, a combination of computer science, electronics, mathematics, etc. Machine learning, this machine learning is nothing but the data science and prediction, how to choose a correct algorithm and apply it on the existing data set, come up with the useful insights for decision making. This is the subset which is picking up with the large contribution from mathematics and statistics. We will spend few minutes on this machine learning algorithms. And a subset of machine learning is deep learning. Deep learning is a further refined version of this machine learning where the data volume is very huge and people cannot manually sit and process or supervise it. So we train the machine to act as a human brain, uh, just like the way our neurons are connected to each other and information is our human learning consists of a sequence of activities. We visualize, we see something, then we record it, and then we send it to set of neurons which are processing it in various steps, and finally we come up with the result. Let's say we see an animal at a distance. We do not know whether it's a goat or a dog. Uh, if you are driving your vehicle and if you see something crossing in your car or a bike at a very long distance, sometimes a small dog or a cat might be uh, passing. So just like the way within a second, we are able to identify whether it's a dog or cat. We will not go near that and then, okay, this is a, I want to look at the size of the legs, length of the body, etc. And then only I will tell whether it's a dog or cat. No. Our brain has captured lots of images of dogs and cats. Just by looking at the shape from a distant place, we can say whether it's a dog or cat. Just like the way the deep learning algorithms are training the machines with large amount of pre-trained data sets, labeled data sets called dogs, thousands of dog images or thousands of cats images we will use to train that computer. And when you take a photo in your camera or a computer and give it, it will say that it's a dog or cat. So that type of intelligence we are building by training the neurons similar to our human brains, which is called deep learning, which is very, very high demand in the industry and also in the research. Lots of deep learning algorithms are coming up where our mathematicians and statisticians can really take up lots of research projects and our industry, academic industry related research projects and published papers. So that field is still evolving. Google, Apple, they all are spending lots of money. They are sponsoring research projects in academics and universities. Professors can really come up with algorithms and come up with research projects, get funds from institutes. But we may not have time to go through it. We will concentrate on the machine learning, which is the core component. So what is machine learning? The machine learning is nothing but the machine learns from the data. Uh, just like the way I said, when I look at a animal, I tell whether it's a dog or cat. But if you ask a 1 year old baby, it will say, no, I don't know. It might say it's a cat or dog, I don't know. The reason, because it has not been the child has not seen so many images or real life pets to learn the characteristics or the appearances of the animals. So it's not able to distinguish between a cat, a puppy, or a cat easily. It will say something is running. So the same is the situation for machine. What is needed is first a large amount of data, millions of records or billions of records, which say data scientist has to collect, cleanse, and classify it. Okay, and prepare it for training. Then what we do is use this data set and pick up a ML algorithm, ask the computer to learn this by going through multiple iterations. We call it as epochs. So the algorithm will take the data set in batches and train itself. This is nothing but learning under the supervision of a teacher. Once we train the algorithm, we evaluate whether the computer algorithm is able to predict a high accurate result. How do we do that? We from the data set which we manually identified, whether it's a cat or dog, we will pick up something and then send it to the algorithm for testing. That's why we have a training and testing data. We split that. Normally, if we have a data set, we will get 80% for testing and 20% for training. We will train the system with the 80% of the data and test it with the 20% because we know the output. If we will check the predicted output of the algorithm and the correct output which the expert has identified and see whether the algorithm is able to predict correctly 80%, 90% accuracy. Normally, industries will expect 80 or 90% accuracy. If it reaches that accuracy, then we call it as the machine learning model. That is the data set for training, the algorithm both put together. We call it as the machine learning model, which is used to predict results by taking the real-time data from the industry or outside world. This is the machine learning process. Data set, we know it will be in the form of a table, rows and column. So what is an algorithm? So algorithm is nothing but a mathematical technique or a computer science algorithm. Okay, come a set of computer science pseudo code. Okay, which we will later translate to a program in a mathematics or statistical formula or a computer science algorithm. We will convert to a software and use it for the training the computer. So the machine learning really enables models to train on data sets before we use it for the real life use. This is an iterative process. We train the model until it reaches a very good accuracy. Once it is trained, this can be finalized and it can be frozen as a well-matured model and sent to the field. People will give the input from directly from the real world situation, and within a second, the machine will give the output. Okay. This is how a machine and algorithm works. Now there are this machine learning is still evolving. People are coming up with lots of new algorithms. There are three major categories. One is supervised learning, the other one is unsupervised learning, the third one is reinforcement learning. People are coming up with new research papers on semi-supervised, etc. The third one, which I said, the deep learning, which is based on neural networks. The first three are purely based on our mathematics and statistics formulas. The fourth one, it is a combination of mathematics as well as computer science algorithm. So we don't have time to go through all the four. We will quickly go through the supervised algorithms and also do a case study. So what is supervised learning? So the supervised learning is nothing but a computer learns under the supervision of a data scientist, just like a student learns from the teacher. So how the teacher explains the student, when we went to school in our school days, they would be bringing shapes like uh, cubes, because if they tell us cube, we will think that it's a square. They will really, the square is for a second or third standard student, they will really bring a cube, okay, which is a three-dimensional object, and tell that if you look at this from one side, it will look like a square, but it has three dimensions, it's a cube. So in the same way, the supervised learning algorithm gets trained under the supervision of a machine learning expert. So what it really needs, the data scientist has to collect large amount of data and also mark it as, okay, this is a square, this is a rectangle, this is a hexagon, this is a quadrilateral, this is a triangle. In the same way, teachers taught us, uh, we have to label all our collected data and feed it to the computer software so that it gets trained. So after gets the achieves an accuracy level of 90 or 95%, then you give an image and say whether, you tell me whether it's a triangle or rectangle or a square. The computer will be able to classify it. So such things are called supervised algorithm. Okay. So what really needs is a very strong foundation of mathematics and statistics to train the computer. This is where we are going to see some of our mathematical techniques, and then we will move to case study. Supervised learning algorithms, there are more than 12 algorithms. Almost all are based on maths and statistics formulas. Okay. Very few are mix of maths and computer science and hybrid approaches, but rest of the things are purely based on mathematics. So it's a right time for maths and statistics graduates to start their research in data science or take up an industry project in data science. There are lots of opportunities available. Okay. We will see a few algorithms, and I will just introduce them by giving our mathematical names itself. Linear regression. So if we want to predict something in our statistics, the first thing that comes to our mind is regression formula. Y is equal to ax plus b. You put all the data in the two-dimensional table, calculate the values of a and b by using the calculating the regression coefficients. We know that sigma a minus x minus x bar whole square into y minus y bar whole square by square root of x minus x bar, etc. We know the two formula to calculate a and b. In the same way, we give millions of data to the computer and say you use this formula and learn yourself, calculate a and b and tell me. I will note down and see whether you have achieved the required amount of accuracy of 90%. If it is not, then we will have to go, and the data scientist has to go and collect different, we will have to remove null values, errors, etc. Do the clean data and see whether the linear regression formula calculates correct coefficient values A and B. Then a forecast can be done. Normally, Swell's forecast, population growth, all these things are, we know mathematics can just solve it using linear regression. But when it comes to millions of records, we need a software. So linear regression statistics based machine learning model is powerful in this field. Similarly, logistic regression. Logistic regression is something where we don't use a continuous distribution and plot it from 0 to n. Instead, we use a function to map it yes or no or 0 to 1. For example, let's say a student has cleared a NEET exam and he has got a score of 620. He wants to know whether he will get a medical college seat or not. We cannot go and then look at the chart and say, oh, this is the 610. Yesterday, last year, this was like this. Previous year, it was like this. Manually, how many records are there? Millions of records are there for the past 4 or 5 years. So we will have to come up with a function and tell the computer, hey, we have two factors here. One is community, and the other one is last year cutoff, and there might be some correction factor. Last year cutoff was 610 for OBC. Previous year cutoff was 620. We can come up with the formula by taking the average of previous year cutoffs and then giving the community also as an input. And there may be some correction factors. New colleges might have been added, so new seats might come up. We will have to add a correction factor so the prediction is accurate. So the mathematician will come up with the logic function and then use the data to train the model, which will help the student. If you give 620 and my community is big C, it will say you got 95% chance to get a medical college seat, or it's very less, 50%. You can look for engineering seats as well. The system will be able to predict. The third one is decision tree. Decision tree is like our mathematical logic, okay, tautology. We fire tautological rules, and then finally decide whether the output will be true or false. In the same way, we take two binary tree, and at every stage we apply some decision making tautology to come up with yes or no and find out. So this is a very useful algorithm. For example, physical test method. A person who is taking up a security job or a police constable instructor job, he can just look at all the numbers and use a supervised algorithm and see what is the chance for him to get the physical test passed. Okay. So third one is a classification. This is also based on our mathematics algorithm, support vector machine. This is nothing but plotting the uh, points in a hyperplane. Two-dimensional, we know Cartesian coordinates, but in real life, we will have multiple independent variable, dependent variables. So we have to plot it in a hyperplane and then classify it by choosing the boundary across the planes. So this we call it a support vector machine. Uh, this is mainly used to classify, given an input, whether it is a circle or a square. We can convert our objects into mathematical vectors and then use the SVM method. This is where mathematicians have lots of research prospects. Converting these two-dimensional objects, text, etc., into mathematical vectors involves lots of research and new algorithms. People come up with lots of algorithms like but vectors, continuous bag of words, similarly converting images to numerical vectors, Fourier transformations we apply. Lots of research opportunities are available in this SVM related field. And one more is Naive Bayes. This is, we all know the Bayes algorithm, conditional probability. The probability, the posterior probability, the probability of C, provided that X has happened. The posterior probability depends on the likelihood probability and the prior probability divided by the predicted probability. Okay. For example, weather forecasting. Whether if it is going to be rainy or hot, we will not go and play cricket. If it is windy and if it is cloudy, we can go and play cricket. We will have lots of conditions like this. Now, how to make the system decide, okay, whether I can go and play cricket or whether I can similarly, our forecast, how this cyclone, okay, cyclone prediction, they have the historical data for 100 years. So they used large computers and used these probability models to predict whether there will be rain for next 3 days, etc. Earlier, they were using based on their physics and meteorology, etc. Nowadays, they are also using artificial intelligence for weather forecast. This based algorithm, people are doing lots of research. They are coming up with the Bernoulli Bayes, Gaussian Bayes, etc. Mathematicians have lots of opportunities to take up research topics in this area also. We are running out of time. All the I think we discussed six algorithms. All are based on mathematical formulas. There are few more algorithms. Uh, uh, Unsupervised algorithms are there. Reinforced algorithms are there. Markov process, which we know that Markov chain, the chain which has no uh, uh, standard behavior from state to state. The transition from one state to other one is purely random. Okay, there is no predefined behavior across all the time slots. So the Markov process is heavily used in reinforcement learning. Mathematicians are suggesting Markov, Markov with memory, additive Markov, etc. So people are interested in understanding this random behavior of a data, can concentrate on Markov process and come up with new algorithms. Uh, if we have time, probably we can go deep dive into reinforcement learning later. So all the supervised learning algorithms which I mentioned are based on mathematics and statistics. So it gives lots of opportunity for fresh graduates to pick up data science courses and do an industrial project, which will increase your uh, industrial skills. Okay. Similarly, academicians and research scholars can take up these supervised algorithms and refine them, converting non-numeric vectors to numerical vectors for this supervised learning. And similarly, refining these supervised learning algorithms and modifying to improve the efficiency. There are lots of research opportunities left out. People can continue to focus on this. We saw some theoretical algorithms, how to start a project. Uh, let's say I'm interested in a supervised algorithm, how to start a project. I think we are running out of time. I'll just take 5 minutes and close this. Uh, the iris flower, which is a flower found available in plenty of species in the Western countries. Scientists say there are 262 300 varieties available. So botanical scientists have collected uh, all the categories and measured their dimensions, length, width, etc. But still, no wise person cannot predict clearly tell whether which type of iris it is. We have taken three for our understanding: iris versicolor, setosa, and virginica. By looking at this, for our clear understanding, there we have taken light blue, dark blue, violet, etc. But some of the times the color might be same, only the dimensions of the petals and sepal might vary. So a novice person cannot tell whether it's a setosa or virginica. Then how to classify it? There are billions of data collected by people doing the botany research. How to help them as mathematician? How to help them to classify this? So we try to use machine learning. For example, a botany research scholar or a scientist would be having a spreadsheet, Excel. He will have a sepal length, sepal width, petal length, petal width. A scientist or a professor will come and look at it and say, this is setosa. Only an expert can look at the dimensions and say whether it's a setosa or whether it's a virginica, etc. Like this, they have classified, and there are data sheet available in the Google for researchers to take with 5,000 or 10,000 records. But researchers are still collecting data 10,000, 20,000, etc. And the industry people cannot go and look at one by one, row by row, and then give the classification. Lots of data scientists have taken up this for research and come up with the machine learning algorithms for prediction. So the row will have four columns: length, width, petal width, length, and sepal length width. Similarly for the petal, length and width. So the expert's job is to look at the four numerical values and say whether it's a virginica or setosa. It's a high, tough job. Only biological scientists can do it. Now, we make this easy by applying our data science. Like I said, three things we need to do: visualization, analysis, and then choose a machine learning algorithm. First, we visualize the data. Visualize is the data. I told more than 10 diagrams are available. We have to choose a right diagram and visualize it. So the pair plot, which says it can do a pairwise analysis of the distribution. So we do a pairwise plot, which is drawing the data in a two-dimensional Cartesian cluster diagram, pairwise petal width and petal length. Similarly, sepal length and sepal width. If you look at this, uh, we will be clearly able to tell that the blue color is easily identifiable, but there is some border clash between the orange and green. Okay, blue is standing out; it's an odd man out, which is nothing but setosa. Setosa is an odd man out. Anybody can identify, but there is this ambiguity involved in identifying versicolor and virginica. So this is the visualization technique that helps us to understand the uh, patterns and classes of the categories, etc. So next, what we do is, okay, just by doing a pairwise plot, we have identified that three groups are there. The one is blue, the other two are boundary conditions. Now let's do a bar chart. So if you do take average of the length width of sepal and petal and do a bar chart, this gives us really some more insights. So we know that Setosa is the shortest one, Virginica is the longest one, but Virginica and versicolor are closely related to each other. There is very little deviation in their length and width. So this is the conclusion we arrive at. The three can be identified just by looking at the sepal length, width, similarly petal length and petal width. Now, how to choose a machine learning algorithm? So the machine learning algorithm, we know that we saw that this SVM, support vector machine, it's a classification algorithm. So what we do is we can go and do the support vector machine and give this input. People, sorry for showing the Python code. People who are familiar with Python can just go through it. Otherwise, I just a description that there is a trained model available in the Python, which is library. We use that. We load the data from Excel sheet or comma separated values and give it to the model for training, which is nothing but if you see the screen, there is something called SVN fit, the line number 7, where we give a X train, Y train. We are feeding the training data to generate the model. Python libraries are already available and it learns. Then we pick up some input data, X test, and call it the svn.predict, which gives the prediction. The output I am printing at the bottom, the accuracy is almost 96%. So that means we can rely on this algorithm for classification of iris. Now what to do? People will have field values. They would have collected 4 vectors, 3, 2, 1, 0.2, petal, sepal length, sepal width, petal length, petal width. So when people bring data from field, we just form an array and then call the predict method on the SVN, which will say whether it's a setosa, versicolor, or virginica. I am giving 3 numeric input to the prediction system. It says first one is Setosa, second one is versicolor, third one is Virginica. Uh, since we have already confirmed that the model has 96% accuracy by validating with the expert output, we can rely on this. And this helps us, the biological scientists, to classify their data and then do further research. This is one of the case study. Similarly, lots of data sets are available in Google. Kaggle is a website where we have lots of data sets, like I mentioned, classifying cats and dogs, distinguishing different species of flowers, different species of animals. Data sets are available, and people can pick up the data sets and try 1 or 2 algorithms and then publish papers how accurate it is. Or we can come up with an algorithm to convert the non-numeric data, the words, images to numerical vectors, and then compare our accuracy and publish paper. Lots of research area are available in this field. Okay. As a concluding one, people who are interested in taking up industry jobs, Lots of industrial applications are being developed. Google, Apple, Microsoft, they all are coming up with the face recognition and natural language recognition. If you speak, the phone will identify your language as well as meaning. If you want to open your a phone, you just capture your photo, it will recognize your face and allow you to log into the phone. Okay, so face recognition, natural language recognition, similarly medical diagnosis, cancer diagnosis, diabetes diagnosis, lots of data sets are available. People can take up and do research projects. This is a new area. We would have thought, okay, maths and statistics people will have to either take up a teaching job or we will have to write a competitive exam and take up a job in bank. Okay, it's no longer the case. Jobs are available in Microsoft, Google, Apple, Infosys, TCS, everywhere. They are ready to hire maths and statistics graduates with the programming skills. Similarly, professors can also take industry projects and get sponsorship from the industries. There are lots of opportunities are left out. I believe it would have given you enough idea to start, where to start with. How can I take a topic for my data science work? How long will I continue to do my research in algebra and then trigonometry, etc.? Can I get into a real world application? Yes, there are lots of opportunities. Uh, uh, Please read Google and jump into data science. Your future will be really good. Whether you want to continue to from mathematics professor, you can become a data science professor, or you can become a data scientist in RBI. Lots of opportunities available. Sorry for taking little longer time. I once again thank you everyone. I thank our professor and HOD sir and Jackson sir for giving me this opportunity. If you have any question, we will spend 1 or 2 minutes or 3 minutes and to answer the questions. Thank you. Thank you again.
Thank you very much, sir. It was a pleasure to have a resource person like you. There are two questions in the YouTube chat box. You have already answered one. One is what are the applications of data science? You have give a clear idea.
Yes.
One of our students asked a question that, sir, after completing UG degree in mathematics, uh, what are the opportunities in data science platform for them?
TCS is hiring BSc graduates for data science jobs. BSc Computer Science, BSc Max people can also join. Similarly, state banks, ICICI banks, reserve banks, they are hiring data analysts. That means not prediction, because at graduate level, you might have exposure to only pie chart, bar charts, etc., correlation coefficient. You may not have exposure to machine learning algorithms. So data analyst jobs are available in the banking industry and financial industry. All that you need to do is gain some skills in creating charts using Excel, MATLAB, SPSS, etc. If you have time, you can take a course or you can do self-learn and apply for data analyst jobs in the financial sector, which is really starting point. But don't stop with that. After that, do a PG course, either in MBA data science or a MSc data science, and try to learn machine learning also. Okay, good luck.
Thank you so much, dear Victor sir. And it's time to thank our
I'll stop.
our
Stop sharing.
participants and also others. Yes, sir. Yes, sir. Yes, sir. So, being the organizing secretary of this wonderful faculty development program, it's my privilege to thank them. Is my screen visible to you?
It's visible, sir.
Okay. So now I want to thank all the personalities who have supported us throughout this faculty development program. So first of all, I would like to thank our honorary secretary, sir, Shri APC Chokalingam, for allowing us to conducting this faculty development program uh, organized by our PG and Research Department of Mathematics. Thank you, sir. I would like to place my sincere thanks to our beloved principal, sir, Dr. C. Veerabahu, who is the being a massive support to all the activities happened in our college. So thank you so much, sir, for your motivation. Next, I would like to thank all the resource persons in our faculty development program: Dr. Mahadevan, Dr. Kala, Dr. Sivanyanam, Dr. Marudai, Dr. Nagarajan, Dr. Palani, and today's resource person, Victor Rajan, for their valuable and wonderful lectures, which have enlightened our participants as well as our students. I also thank the entire team of Department of Mathematics for rendering their hands to conduct this faculty development program in a successful manner. Thank you, dear colleagues, for your wonderful support. And I also thank Dr. John Prince Soundaranayagam, our ICA coordinator, and Dr. D. Radhika, our ICA custom coordinator, Director Stride, and Professor Gomadi Nayagam, head of the Department of Computer Science, and our non-teaching Miss Sandana Selvi, for giving us the opportunity to do it in YouTube Live. So these are the faces behind the YouTube Live. So thank you so much for your kind help. And also, at last, dear participants and my dear students, you serve success to any of the event. So without your active participation, this faculty development program would not be a grand success. So thank you, dear participants, for your active participation. Thank you all. If I missed anybody, I thank them also. So at last we came to a conclusion of this faculty development program. Once again, I thank one and all for this grand success. So I have shared the feedback link in YouTube chat box and also in the uh, Google Meet chat box. You can fill the feedback link. You guys, participants, will receive their participation certificate within a week, since we have to consolidate all the 7 days program feedback. So kindly give us a 1 week time to give you the participation certificate, and the participation certificate will reach you within a week by mail. Thank you one and all, especially today's resource person. Thank you, Victor sir, for your
Thank,
immense participation.
thanks for giving me this opportunity. Thank you, everyone.
So thank you all. You can fill the feedback form, which have shared in both YouTube and Google Meet chat box. Thank you all. Thank you.